There we go. Okay. We've been talking about these relationships, and you talked about graphs. The most important thing is that you can read a graph. You'll get used to this recording after a while. All right? Okay. Yeah, Greg. Yeah, that's fine. Try to come back when you can, though. You have to take that with you. All right, so right this here, it's about Bob. Bob's got a cell phone. And you guys have all those questions in front of you. Bob's cell phone is about how much it costs each month and how many minutes he uses it. You guys got that so far? I'm going to make this a little smaller so we can see some of these questions. All right. All right, so everybody has asked a bunch of questions. When is the graph increasing? When is that graph increasing?
When it starts.
Yeah, I want you to look at that graph, but when is it increasing?
At 30.
At 30? Is it increasing the whole time? Mm-hmm. Right, so what we're going to say, this thing's increasing the whole time. I want you writing this down. Some of these questions we're going to answer is going to say yes. Some of it's going to be no. Some of it is going to be never. It all depends on the type of function we're talking about. Yeah, right.
Sorry, I was going that a little bit, but also about the notes. Do I take them? Or
you can take them. I'm recording this. Go on the score later on, and then it should be on to download the video. All right. So it's increasing the whole time. You guys get that? All right. Next one. When is it decreasing? When is that graph decreasing?
Never.
Right, it's never decreasing. So it's never decreasing. All right, you guys got that so far? Jeremy, you got it? All right. All right. When are the turning points?
There is none.
Right, there aren't. Remember turning points where a turning point might be, yeah, it might go from this to this. That would be your turning point. Well, there are no turning points in this case.
Just a straight line.
Right, because it's a straight line, right. Where other there are none.
Yeah.
Okay. When is the graph positive?
Always.
It's always positive. And we're going to see a whole bunch that are just, it's always positive. And when is it negative?
Never.
Okay, you guys got it so far? All right. So far this is super easy and we haven't done anything differently. I'm going to move this down and it's going to disappear. Jeremy, I'm going to get you a copy of this in a little bit, okay? You just pay attention. You can take notes if you want, but I'll get you a copy in a little bit. All right. All right. When is the graph negative?
Never.
Didn't I just go over that one?
Yeah.
Sorry. What are the maximum? What's the highest point on that graph?
1000.
Okay, 1000. What's 1000?
After 9, it stops right there.
Okay, not at 950.
Yeah.
Okay. Okay, so isn't our highest point right here?
Yes.
All right, so the highest point, that's our maximum. Could that go on any further than that?
Yeah.
It could keep going, couldn't it? All right, so our maximum is, right now it's, I'm going to write this down, it's 950 is the minutes talked. Might help if I give you enough room. 950 minutes when you talk, how much would that cost the person?
900 and...
Well, hold on a second. This is 950 minutes. That's this part. Where does it go over to here?
122.
Let's say, I'm going to say 125. My line didn't draw too straight. I'm not real good at drawing that. So the maximum right now, the maximum you can see is 950, 125. Now that means this is the x, or this is the domain, and this is the range, and you guys know that, but it's also something else. It's $950. Bob will pay. I'm sorry. If Bob talks 950 minutes, it will cost him $125 because this is minutes talked. Okay? Got that? Can I move this down?
So the minimum is 950.
The minimum is not the minimum. See now, what is the minimum? What is the minimum? Okay, but you got to get. You're right. It's 30 to 0. But what is the 30? Is it minutes talked or cost in dollars? Right. So when we lose things, when we write these things down, we talk about your x's or your input or your independent variable or your assistant first. So this would be 0, the minimum is 0 and 30. So that's your minimum. Now it doesn't go any further than that because you can't talk on the phone for negative minutes. It's one of those things where it's just positive. All right. Number 8, I'm going to move this down. Click. Is this relationship discrete or continuous? Any idea?
Continue.
Okay. Why do you say it's continuous? Right, well, also because it's a line. Now, Vito, if something is discrete, it's going to look like this. They're going to be individual points. If I would take everybody in this class and say age to height, age might be my x, height might be my y, we're only going to have 1, 2, 3, 4, 5, 6, 7 points because it's 7 people, and that's discrete. All right? Domain. JJ, what does domain mean? All right, Vito, what's the domain? If you start right on the board, right there near the phone. No, what is the domain? It's your x's. All right, so anything that's an x is going to be a domain. And so our domain is everything from here on this way. Got it? So we're doing something new here. We're going to use these fancy math terms. Not fancy, it's like math symbols. We're going to call it x. All right, x is just what we're unknown. Now, since I'm going this way, it's going to be greater than. Greater than or equal. Remember that symbol from 8th grade?
No,
That stands for greater than or equal to?
yeah.
The other one's less than or equal to. So it's greater than. Where do my x's start? Do I have any negative x's?
Well, you could, but no.
Well, can I talk for negative minutes?
No.
No. So it's x is greater than or equal to 0. Any number that's greater than or equal to 0 could be my domain. You guys got this so far? You guys afraid to talk? I'm recording this. I kind of like this. Are there any restrictions to the domain? Are there any places where the domain can't go?
No.
Okay. Remember, if I have a graph, my graph really goes like this. Can I have an x that's in the negatives?
No.
So it has to be greater than 0.
Yeah.
So it has to be greater than 0. And there's actually one other one that's kind of difficult to
The
understand.
range.
Well, we're just talking about restrictions on the domain. When you pay a cell phone rent, how long is the bill cycle? Is it for a day, a week, a month, or a year? It's every month, right. So, how many minutes are there in a month? There's a lot. All right, let's figure it out. How many minutes are in an hour? 60, right?
Yeah.
How many minutes are there in a day? How many hours are there in a day?
12.
So take calculator out. It's 24-hour day.
Wow.
What's 24 times 60? All right, so that's how many minutes there are in a day. So you could speak for 1,440 minutes in one day. Okay, you physically might not be able to, but you could. How many days are there in a month? What's the longest month?
June.
No.
December.
Let's say 31. All right. So what is 1440 times 31? What's 1,440 times 31? That'll be the number of minutes that are in a month.
Times what?
31. So you got 44,640?
Yes.
Okay, here's the restrictions. Chances are, some of you can probably talk on the phone for a long time. I'm assuming, right?
The mom can.
Can you guys at least say something so if somebody thinks, oh, no, he's talking to nobody? All right. Some of you can talk for a long time, but none of you can talk for this amount of time.
And no.
Physically. But our graph would go that far. If you kept your phone on and kept it charged, it would just keep charging, wouldn't it?
Yeah.
So, the restriction greater than 0 greater than 0, but x is greater than 0, and it's less than or equal to 44,640. So you can't speak for more minutes than there are in the month. Okay? Does that make sense to everyone? Yes. All right. Well, what is the range? Range is the
Y.
y's. So where do the y's start?
At 0.
The y's start here. So where does it start at 30, right? So x is going to be greater than or equal to 30. You got that? All right. Number 12. What is the y-intercept? Where does this line cross the y? This is a linear function. Where does it cross the y-axis?
950.
Okay. This is the graph. It goes like this, and it goes like this. This is your x, and this is your y. You guys with me?
Yes.
Okay, Jeremy, where does that cross the y-axis? Can you see it from there?
In the middle,
Okay, the middle, but what is that number?
140.
140. 140 is way up here. This is the way the line goes. Where does that cross the y-axis?
80.
It crosses at 30. Maybe you couldn't see that from back there. Okay? It crosses at 30. That's where the y-intercept crosses. You guys need to know that. And what does that represent? What does that mean when it's crossing at 30? What sort of charge is that? What is the $30? If your phone bill is $30, have you talked on the phone at all? You haven't talked on the phone at all. Look here. If my charge is this amount right here, how many minutes have I talked according to the graph? I've talked 0 minutes. All that $30 is a service charge. That's a service charge. And you've spoken 0 minutes. You got that? All right, 2 more, and then I'll stop this video. What's the x-intercept? Where does it cross the x-intercept? Does it cross the x-intercept?
No.
It doesn't cross, because the x-intercept, remember the graph keeps going like this. Our graph does not do this.
It can't.
No, it can't, because you can't speak negative minutes.
Yeah.
So there is no,
No intercept.
none. So they don't always have an x-intercept.
Yeah.
And the last one's an easy one. Is the rate of change constant?
Yes.
How do you know?
Because it's just going straight line.
Right, and it's yes.
So we stop the video.
No. You guys got any questions on this? You can start talking now that I stopped this?
Yes.